Greetings once again, everyone, and welcome to Trigonometry for Students and Surveyors. We're up to Lesson 9. We're going to continue with oblique triangles, solving them, laws of cosines, laws of sines. There's side, side, angle, 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 side, 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 side. That's some of that's on the other side of my board. We'll be flipping this board. So let's get right in it. This is the if you don't have this opposite side of the angle, you need to use the law of cosines before you can start using the law of sines. You need to have a distance opposite that, so we'll do that with the law of cosines first, then we'll flip over to the law of sine. So we're going to solve for A over here, and the formula is for A, b squared plus c squared minus 2 times b times c times the cosine of the angle A, which is 36. So over here, we're looking for A, so we just leave that out. B squared plus C squared is this number, 39,971.0766. Then we're going to go 2 times B times C times the cosine of the angle, 36. Remember, it's always across the opposite, just like it was in right triangles. And you'll notice these patterns. I keep saying that yesterday and today. You'll start to see these patterns, how the sides work, how the opposites work, and then you'll start to figure out what function and which ones to use. So that is 3208. You subtract this from this. Now I was going to talk to you about the calculator. I can run this whole thing in this HP35S. Just go a squared plus b squared and the whole thing and come up with the answer. You can also do that with the 42S, that downloadable one, that app for your iPhone and your Samsung. The only difference between that one and this one is that one you have to hit enter when you store, and enter when you retrieve a number. But it also has the alphabet that you can store numbers under. What I do on this one is I store. I enter all my angles and distances in, so I put all my angles across the top, because when you hit store, you're going to get the alphabet comes up, and this just happens to be A, B, C, so I store angle A, angle B, angle C. I skip a row, because I can't really use that whole row, so I go straight down below that to this next row, and directly below angle A, I store side A, side B, and side C. It just makes it really handy when you start doing all your calculations. You don't have to re-enter everything. You're also storing the extra decimal points that it doesn't show, that you can find out when you hit show. Okay, so b squared plus c squared. So get to know your calculator, practice it, and then also use your graph paper, your protractor, your scale, and draw these out on your grid paper, on your graph paper, and look at your angles on your protractor, look at your distances on the scale, make sure you're using the same scale for every side. And then you get a lot of good practice that way, and you'll have a whole tablet full of really cool triangles you can show people. 8b squared plus c squared is that number. 2 times b, so it's minus 2 times b. We save the minus for now. 2 times b times c, because we use multiplication first, is the order of in algebra. Order of operations. 2 times b times c times a cosine of 36, and that's this number. Don't forget the cosine of 36, and that's this number. Now you minus, you subtract that from this, and now this is your number you get, 7890.7535. And now you want the square root of that number, and that square root is 88.8299. That's side A. So we're going to go ahead and fill that in now, and that's how we've done side A. Now where that's handy, especially if you're a surveyor and you're calculating a curb return or a road curve from the PC to the PT, you're going to get a delta angle It's not always going to be 90, but you're going to get a delta angle. And one of the dimensions on that delta angle is the chord length. This would be your chord length. This would be the radius point. This would be your angle. These sides would represent your radius, and they would be exactly the same. And then this would be, so you could calculate your chord that way. The other way to do it on a curve like that is to use two right triangles. That's the other way to do it. You can do both and then check each other. That's what I would recommend. So that's handy for that. Another thing for surveyors, students might want to know this too, is you might have two control points here, and you can't see between them anymore. You can't set up on one and backside the other one because they put a container or something in the middle of the way. So now you need to do a resection. Well, this is a triangle. Resection is just a triangle. That's all your data collector's doing. This would have a coordinate on it. This would have a coordinate on it. And now you're sitting wherever you choose to sit. You're measuring here. You're measuring the angle, the right angle. You're measuring here, and your computer is calculating the coordinate for you right here. So that's what's going on. It's just oblique triangles working in reverse, and we're going to use some more examples of that later on. So there's that answer. All right, so now we're going to go solve for angles opposite the known side. Here's your formula: cosine A, b squared plus c squared minus a squared. 2 times b times c is the arc cosine. So it looks like I picked out, we already had a done, so I guess I picked out b for the example here. So b is a squared plus c squared minus b squared divided by 2 times a times c. And then whatever that division is, then you get the arc cosine. So we're going to go a squared plus b squared, a squared plus c squared. Where are we at here? We're trying to find b. So we got these two sides. This is the one that's going to be the opposite. This is sort of the ones, they go in pair, these go in pair. So a squared and b squared is that, minus b squared, a squared, c squared, sorry. B squared is that number there, and then you minus that, 1219, then over 12,919,6,746. So that's a squared plus c squared minus b squared gives you that number. You divide that by 2 times a times c, and you get that. So 2 times a times c, and you get 0.48. Your ratio is 0.4848. And now you want the arc cosine of that. No, I think we're going into sines now. Arc, well, let's just see. 4848. We'll go arc cosine. Yeah, that's 61 degrees. So, yeah, that's right. We're still in the law of cosines. So that's 61 degrees. There it is. So, arc cosine. So we're going to go here, 61 degrees. And that was for B. And now we'll do C. C is a cosine of a squared and b squared, or a squared plus b squared, and that's that number, minus c squared, which is that number here. That's that number, and then 2 times a times b, and that's that number, and then you divide those, and you get 0.1219. Okay, so let's just figure that out. A squared plus b squared. I'll just go ahead and work this one out. So I got recall a squared. I got recall b squared plus, and that's 253. That's what that is. Now we want c squared, so that's 150. So I just hit recall c, hit squared, and then minus 2861, and then now we want, that's that formula up there. Now we want 2 times a times b. So I just leave that in there, 2, enter, recall side a times recall side b times 23,482,7526. Now divide 0.1219, and now we want the arc cosine 83. So up here is 83 degrees. And there's no conversion because they're just even degrees. So we probably should check those. Let's go with my numbers here. I got recall A is 36 degrees. Recall B is 61 degrees. I'll just hit plus. Now we're up to 97. Now we're going to go recall C is 83 degrees and plus, and we have 180 degrees. So that checks. And I think, what was that? Aliens. I think we've got it all. You did that one, and that one. So that's good. All right, lesson 09, halfway there. Then we flip the page. We're on the blue side. We're back here to this. We're over on this side now. We're going to look at law of cosines. Requires you need to start with the law of sines. You need to work. If you don't have the angle opposite a side, you need to create that first. So that's just kind of blocking your line there. So what we have here is 120 degrees. This is like that resection I was telling you about, except, well, yeah, they can be different lengths. The delta on a triangle, on a curve, they're going to be the same length because they're going to be the radius. But anyway, so we're going to do this. We're going to try to solve for this opposite here. A squared, B squared, C squared. So I'm going to go, these are pretty even numbers. So we'll go A squared plus B squared is 6,100. That's what these two numbers are. 2 times A times B times the cosine of the angle 120 is 3,000. It's a negative 3,000. And you subtract those and you get 9,100. And now you want the square root of that, 953939. And that's what we have here. So I'm just gonna work that in the calculator for you there, A squared plus B squared. So we're going to go 60 squared. We're going to go 50 squared plus, and we're going to go 2, enter, 50 times 60 times, and then we want the angle 120 cosine, that's a negative 5, and times is a negative 3,000. Now we angle the cosine times, and now I just need to hit minus, and that's 9,100. Now I need the square root of that right here. I need the square root of that, so square root of that is 953939. So that's, we can pull the happy face off here now. Now on these, I didn't enter these and store them and recall them because they're basically numbers. They're just easy numbers to remember, all these. So I could start doing that now if I wanted to, 9539. So now we're going to go, all right, so that's how you solve the opposite side when you have those two sides. That's called the law of cosines. Law of sines. Now we want the missing angles. Sine of A, let's find A. We don't know what that is. We're pretending we don't know what that is. So A would be 50 over the sine. Okay, now here's what we're doing here. This is the angle we're looking for. So we're putting in the opposite first. And then, okay, so then we have, all right, here we go. We're looking for this angle. We're going to put in the opposite first. So that's the opposite side is 50. Enter. Now we're going to go 120. Now you're going to see that these will match up. 120, and that's the sine of that, times, multiply that. That's 43,3013. Now you want to divide that by the opposite of the angle. 9539. 0.3939 divide, and I got 0.4539. That's the ratio. Okay, now you want the arc sine of that, not the arc cosine. We're working on sines now. We use cosine to get this. Now we're working on sine. So the arc sine of that is 269955. Pull the smiley face off. 269955, and that converts to 26 degrees, 59 minutes, 44 seconds. Okay, I know this gets a little complicated this way. You got to have these formulas, and you got to practice. It's kind of fun to do. Let's do another one. Let's go B. So B, just so you get the we're looking for the opposite now. The side opposite the angle we're looking for. So that goes in first. 60, and then we want the sine of 120, so 120, and we want the sine of that, and we want to times that, and then divide it by the opposite of this, 95.3939. Divide is 05447. Okay, 05447. Now we want the arc sine of that. 330045. We'll take our smiley face off here. And then this is 33 degrees, 0 minutes, 16 seconds. And that's how you do that. Now this can also be done, that's the sine. So we've got everything figured out now, the distances. What if we did this backwards? Let's do this backwards. We want to figure out this angle here. So we want to go C over sine B. So remember, we always put the opposite distance in first. Here we put 60 to solve that one. We put 50 to solve that one. So now we want C over sine B. Now this could also be sine A. We just have to use a corresponding angle, or we use B, so we'll have to use this corresponding angle. Okay, so let's go with 953939. I'm going to store that as 9. I'm just going to write that here, 9. Okay, now that is, and then over the sine of B, and that's going to be 330045. And that is the sine of that times, and 51965. Now we're dividing that by 60. Okay, so 60 divide 8660. Now we want to arc sine of that. So arc sine, and that gives me 60 degrees, not 120. So this is an obtuse angle. It's greater than 90 degrees. So when that happens, you got 60 degrees. Subtract 180. 180 minus 120. Again, it's going to be hard to remember all this, but it is on video now, so you can refer to the lesson 9 and go over these. You can look at these. You can take screenshots. And that's it. This one here is solving, we solved this angle. This was the law of sines to solve that one. This was a cosine. This is side, side, side. We just did the one example here. If you just have three sides, you can solve the angles on those sides as well. So this is b squared plus c squared minus a squared. So b squared plus c squared. This is b squared plus c squared. And that's what that equals. Minus 50 a squared is that. So you subtract those two, or divide, sorry, you divide. Divide times, okay, so b squared plus c squared minus a squared. Then divide by 2 times b times c. And your division comes up to 8910. And now you want the arc cosine, not the arc sine. So if I went 0.8910, arc cosine is 27. Yeah, I got 27 because I'm using numbered decimals that were not entered in the calculator. So this must have been changed a little bit. So we're up to, we're only a few seconds here, 6 seconds from 27 degrees. So now I got 27 degrees. So that's fine and dandy. 2703. So we're off a few seconds here, and that has to do with the decimals. So because I didn't store that, when I calculated that, I didn't store it because that would have stored out, and eventually it would have pushed them over. So, so that is, we've been working with sines and cosines, and like I say, I don't, you know, I wouldn't be able to memorize all this stuff. I just learned it from doing it over and over and over again. You're going to have to get some cheat sheets. There are some, if you're a surveyor and you have your access to a data collector after work, take it home. There's a COGO program in there, and you can go in there and you can have a triangle calculator, a solver, angle solver, bearing, intersection, curves. You have all that stuff within your COGO menu. So if you're not familiar with that, get familiar with that. And you can work these out and then use that to check, but don't just go straight to there because you'll never remember. Failing that, you don't have a data collector at home. Anybody can go online and look for angle calculators. I was going to put a link into them, but I started looking, and there's so many different ones, and I don't really know which one a person would prefer. But you could go in and find an angle calculator, and they just give you blank boxes and distance, and you put in 2 or 3 elements and hit solve, and then they'll solve all the other elements for you. But like I say, it's not going to do you any good just to do that, but it will help you check your work, and that's why I would recommend going into the website and finding some angle calculators to help you out on that. So that's about it. So that's side, b squared plus c squared minus a squared, and divided by 2 times b times c. Then whatever that ratio is, then you get your arc cosine, and then there's your number. So we came up with the exact same number here as we did over here when we use the law of sines. So just remember, you're always going to get, these would be a pair, this would be a pair because that's the side opposite. And I guess that's about all, folks. We are going to start coordinate geometry in the next lesson, lesson 10, I believe. All right, thank you. Oh, like and subscribe, please.